Good afternoon. This is the session you were all looking forward to, not just because it's the last session of the week, but because it's the routing area open meeting. I'm just going to wait for someone to close the door, then you can all burst into applause and cheers and everything else. Yeah. Nothing. There we go. Thank you. Okay, so welcome to the routing, where are we? Routing area open meeting. Okay, thank you. I am Alvaro, this is Martin, and that's Deborah. So please don't get confused.
What are you again?
Bob. Okay. I'm the other guy, yes. So just to make sure, yeah, well, whatever. Okay, so this is Nodewell. I have, even though many of you think that you have seen it many times, please look at it again. First of all, because I've seen many working groups show the old version of the Nodewell. This is the actual right version. Now, this version talks about intellectual property, yes, just like the old one, but it also has pointers to things like the code of conduct. How many of you were at the IETF plenary last night? Okay, maybe 6 of you. So there was a long set of people, too many for my taste. One is too many, honestly, who came to the microphone to talk about not the best conduct in the IETF. People being attacked directly, people not being given the chance to express their opinions or to explain their ideas. And so it's important that we understand that that is obviously not the way we should behave in the IETF. I have no specifics or no knowledge of anything of this happening in the routing area, but it's important for us to be on the lookout for that, especially for the chairs as we conduct our meetings, to make sure that we give everyone a chance to speak, everyone a chance to present their opinion, defend their proposals, whatever they're doing. And that's the other reason why, again, the Nodewell is important, because it talks about intellectual property, and some of the links at the bottom are about, for example, the code of conduct and the anti-harassment procedures in the IETF. So please make sure that you read them and you're familiar with that. There's also some links that we have here for other materials in the routing area that you can go take a look at after the meeting. There's blue sheets are going around somewhere. Is anyone on the Jabber room by any chance? Can someone please get on the Jabber room just in case we have someone? Thank you, Drew. Over there we have several people remote. If the remote people are listening, which I hope they are, yes, you can use the Jabber room. If you want to say something, you can also come to the mic and we'll see you from here, and we can let you speak as well. So here's the agenda. We're going to talk about the area, of course, first. Then we're going to have the Routing Directorate report, and then we're going to have an update 1 year later of where we are with DC routing work. And then hopefully at the end we'll have some time for any other things that you guys want to talk about. So as always, we want to request that you review documents. We, us three, and the rest of the ASU, of course, have to read everything. And sometimes it looks like the documents were not reviewed properly in the working groups. We do have the Routing Area Directorate, which does a lot of reviews, and it helps a lot. But please make sure that there are people reviewing the documents through adoption and last call and discussion. If you need to grab volunteers or volunteer someone, please do that to make sure that the quality of the documents goes up as much as possible. Tony.
Tony P. So first comment. So I was like, I was thinking that the shepherds were mildly useless. I completely changed my opinion in this respect. They're excellent. Specifically in this respect, right? If you get a volunteer special eager guy, he will just come through this thing. Yeah.
Thank you. Thanks, Tony. That's a really good comment. Shepherds are not only supposed to review documents as well as the chairs, they're supposed to also shepherd, that's why they're called shepherd, the document through the rest of the process. So if you're a shepherd, remember that your job doesn't end when you fill out the shepherd write-up. That's just the beginning, right? You still have to go through the whole process in case there's some stick up with the IEG or some review later to help the authors go through that. Yes, we want everyone to do reviews, right? We expect shepherds and chairs to do it, but we want everyone to collaborate. I mean, this is why we do working groups, right? We don't do individual documents. The product is the product of the working group, not just of the authors. One of the things that we've noticed is we've been reviewing documents is that not all of you are aware of the new changes that came in RFC 8174. RFC 2119 is where all the normative language is explained, must and should and all those nice words. There's sometimes this confusion when we use capital letters and non-capital letters in the text. And so 8174 clarifies that. This is the whole text that changed from 2119, which basically says that when you use capital letters, they mean what 2119 says. If you don't, then it means whatever the dictionary says that word means, right? It also says something else that is important in that not every specification to be normative has to use 2119 keywords. But you can still make a specification normative and clear without necessarily using those words. So just the action here is please make sure that the documents don't have the old 2119 boilerplate, but that we use the one at the bottom here that lists the keywords and also makes reference to BCP 14, which is 2119, and this new RFC 8174. We're always looking for feedback. Please talk to us about ourselves, talk to us about each other. Any way you want to provide us with feedback of things that we're doing well, or especially things that we need to improve, please let us know. This time of the year is very important because, as you know, the NOMCOM, or as I hope you know, the NOMCOM has been doing interviews for routing AD replacements because Deborah and I both expire at the next IETF. So please go talk to the NOMCOM. They're still here. There's several of you in the room who are part of the NOMCOM. Carlos, can you guys stand up so they see you? Victor, is anyone else in the NOMCOM here? I don't see you. But in case you want to give feedback, you can talk to them. You can go to the webpage, datatracker/NOMCOM/2018, and provide feedback there. The feedback can be anonymous if you want to. I'm sure that you can tell them and give them anonymous feedback, and that they can anonymize it for you as well. Usually they use that not only to make the selection for routing AD, or for any AD in this case, but they have been doing, for the last couple of years, they have given us feedback on what the community says so that we can improve. So if you don't feel like talking to us directly, especially if the feedback is really bad, go talk to the NOMCOM, and they can take care of taking that into consideration for selection and to give us feedback later. Also, this is not just about routing AD. If you want to give feedback about some other ADs, you can do that. If you want to give feedback about the whole AESG, you can do that as well. The feedback is important because we are, of course, a community. Yes, and Deborah just reminded me, the other slate that's out there is the IAB. And there's also candidates for the new IETF LLC and the IETF Trust. If you don't know what those are, please go to the plenary next time. The other thing that I want to say here is that we are always on the lookout to grow the leadership talent inside the area. It is important because the three of us are probably not going to do the AD work forever. The chairs change once in a while, so we're always looking to find people who can do those jobs or are willing to do it. This time, unfortunately, 80% of the candidates for routing AD declined the nomination. That means a couple of things. It means that there was a good pool of people that were nominated. 10 nominees for routing AD was a good pool. But 80% declined, which means that only 2 accepted. And there's 2 slots. So you can do the math, you can add. Now, that doesn't mean that it's an automatic selection. The NOMCOM is going through the process anyways. That's why I invite you to go give them feedback. Because if we are not the right people, or especially if we need to improve, right? Please let them know. The 2 people that accepted it are, of course, Deborah and I. So we're going to a 3rd term. I don't know many ADs who go past a 3rd term. So we need to keep that in mind, right, for the next time. And hopefully we have a lot more people who accept nominations the next time around. So the area status is really simple. We closed 1 working group. We finally finished the work in CIDR and we published all the RFCs, and we rechartered 1 spring. We don't have any new work since the last IETF. This is the distribution of working groups. Hopefully you all know who your responsible AD is. We routinely meet with the chairs, and about once a month or so, we try to do it at least 2 or 3 times between each IETF to talk about different things. We do training sometimes, we talk about area things, we mostly management type stuff. You have always loved this meeting because we used to give updates of the working groups. We used to line up all the chairs and everyone would give a 2-minute update of what the working group was doing. This year, at the start of this year, we changed that a little bit, where we have been using some time to socialize a little bit more, which we did at the first IETF of the year when we had the routing AD change, when IDEA was replaced by Martin. And we've been putting the status updates on the wiki. How many of you know where the wiki is? Okay. How many of you who are not a chair know where the wiki is? Okay. So we figured that the wiki has been useful, but probably not as useful as we would want. So in one of the last meetings that we had the chairs, we talked about changing the audience that we're making the updates for. So what we hope you start seeing now is a status update on the page of the data tracker where your working group is. So you should be able to go look at that and get an update so or more importantly, so that external people, maybe people who don't come to the ATF too much, maybe people who are not participating in a specific working group but do come to the ATF, get a sense of what the working group is doing, what are the interesting things that are going on. So we should start seeing that now. This time we're running this as an experiment. We should still see the updates in the wiki, which is the last link there at the bottom. So that's that. Questions, comments? Nothing? Okay. Everyone still there? Yeah. Yeah. The other thing that we've been talking to the chairs about, and I actually heard it mentioned in a total of 2 working groups that I attended this week. We've been talking about implementation requirement policies. This came from a question that was brought up at the plenary in IETF 102. where it was asked about implementation requirements in the IETF as a whole. Thanks, Stuart. The IAG had discussed that, and we decided it was really hard to have one policy for everyone. So we decided that this would be better served working group by working group. There are working groups that already have policies. Everyone knows, and everyone in the IETF actually knows about IDR's policy, which is 2 interoperable implementations. And there is documentation of that on the wiki as well, on the IDR wiki of the implementations now, etc. But not every working group has an implementation policy. So we have asked the chairs to go and think about that, to consider what the implementation requirement policy for their working group is. So we hope that this soon will come up in a list near you for that discussion. This doesn't mean that every working group should require 2 implementations or interoperable implementations or anything like that. This means that we hope there is a policy for the working group. So the working group may decide that the policy is 5 interoperable implementations. It may decide 2, it may decide 1, it may decide that what we want is a RFC 7942 type section in the RFCs or in the drafts. It may decide that there is no requirement. There's many reasons. What we want is for the chairs and hopefully in conjunction with the working groups to think about this and consider it so that we can actually articulate what that policy is by the working group participants or by anyone else who asks, or by us, or etc. So Stuart, you don't have a question anymore?
Yeah. Surely the
name
Stuart. I didn't realize that you'd put it there, but I was really worried that one size doesn't fit all in any working group. So whatever your policy is, you need the chair exception or the AD exception or something or other, because there are always cases where it's an informational about something, or it's a correction that everyone knows needs to be had, or whatever. There always needs to be an exception.
I agree with you, Stuart, and that's part of the policy, writing down that exception mechanism, I believe.
But I think it's so universal and so uniform that it probably would apply to the whole area regardless of what the current chairs think, because sooner or later they'll discover there's some reason why they need to publish an RFC, and there may or may not yet be any implementations of it.
Agree also, but it doesn't hurt to write it down explicitly.
Okay, anyone else? Yeah, so there's been several suggestions of where we can put this. It could be in the status update. It could be somewhere else on the data tracker itself. Some working groups have a wiki page. When we discussed this with the chairs, someone suggested that maybe we could even make it part of the charter. So one size doesn't fit all, and the intent here is for everyone to have a policy. We are the IETF, we believe in writing code. So it would be good to at least understand what the policy is. There are many reasons why we may or may not require, from not only the protocol that we're developing, the market that we're serving, the type of industry, many things, why you would want or not to have requirement implementations in your working group. Okay, so now we're going to go into the Routing Directorate report. It's going to be John or Amy. If I can get out of this. Yes.
Just to let folks know, John has told us the very bad news that he's stepping down as PCE chair, and also for this. So actually, we're on the lookout for somebody to help Amy. Okay, so if anybody would like to step up to this to help out, they can tell you what it involves, and we'd really appreciate it. And we thank John very, very much for everything he's done for us.
Thanks, Deborah. Okay, so the Routing Directorate report, as Deborah says, it's my swan song for this role. So I'm one of the coordinators. Amy is the other one. You want to give a wave, Amy? Yeah, Zane. So yeah, just to remind everyone what the Directorate does. There's a panel of, last time I counted, 49 routing area experts who are awesome people who freely give their time to help the ADs in processing all the many drafts that we have to get through in the routing area. They're appointed by the ADs. The purpose of having a directorate is basically to ensure quality of the drafts. So we review most of the routing area drafts as they pass through IETF last call. We will review from time to time other routing related drafts at IETF last call as well. If you're a working group chair, you always have the opportunity to ask the directorate to perform an early review of any draft that you have in your working group. It's useful, particularly if you feel that a draft needs more review and you're not getting that review inside your working group, to get some eyes on that from the directorate. And from time to time, the directorate will assist the ADs in making judgment calls about particular issues, although that hasn't happened for a while. You can find out more on the wiki. I got some stats to show you. These are the stats for 2018, covering the whole year. So the graph there on the left shows the reviews that have come in, and the reviews, the blue column shows total, then the orange shows the reviews that the ADs sent to the directorate, and the grey shows the reviews that the chairs sent to the directorate. And you can see that at the start of the year we had a lot of reviews because the ADs were keeping us very busy with 40 reviews in the IETF 101 period. That's tapered off from the ADs in the next two periods, but the chairs have increased the load that they've been putting on us. So it's nice to see where we'd be getting some more early reviews requests coming in from the chairs. I'd like to see more of that, because I think it's actually useful when documents come to IETF last call. If the directorate have already seen them, then we already have someone ramped up on the draft, and the draft has presumably already had the benefit of them looking at it. The graph on the right shows which working groups have been sending reviews to us. And as you can see, there's a mixture of working groups that don't send us anything and working groups that send us quite a bit. But actually most of the reviews, well, probably, I don't know, 1/3 of reviews come from outside the routing area altogether. And certainly no one working group loads us as much as the rest of the IETF. So a few more stats. What do we find in our reviews? The graph on the left shows what do we find when we actually review documents from inside the area. Well, half of those documents we find issues. And occasionally we will send a document back to the working group and say, look, this is not ready. There are major issues and we don't think it's ready to be published. Obviously, that's for the chairs and the AD to really decide what happens to the document, but it does sometimes happen, and that's the 3% slice in the pie chart there. Sometimes we just think that reviews are perfect, and the rest of the time we'll find some nits, but nothing to block the draft. Pie chart on the right is the same thing, but for drafts coming from outside the area. So again, they're pretty similar. I think that generally we find slightly fewer issues in those sorts of drafts, probably because of the background required to review them in depth. But we still do a pretty good job of hunting out issues. And one thing I think is interesting is that these types of graphs are quite stable across time. So I was looking at the presentation that I did 1 year ago, and the pie charts I showed there, and they pretty much look the same as this in terms of the distribution of issues or not.
Could I ask a clarifying question? Are they nits as in ID nits, or are they nits as in minor trivial comments?
Yeah, thanks, Stuart. They are nits as in editorial and or minor comments, which would not block a publication, that we think, fix this in passing.
No, that's fine.
Yeah. So that's it. So yeah, summary, the directorate do very useful work, very good at finding issues. Please use them as much as you can.
Thank you. So now we're going to go into an update on the data center routing work. So if you remember a year ago, we met in Singapore. And in Singapore, we had a BOF about DC routing. The intent of that BOF was to talk about the requirements and potential interest of the community in working on new routing proposals to be used in a data center. Out of that BOF, we asked, how many people are interested in the couple of proposals that were presented there, and there seemed to be interest in that. So now, 1 year later, what we want to do is provide an update of where we are, and also at the same time to try to renew the interest in these proposals and invite people to participate in the working groups as well. So we're going to have an update from LSVR and from Rift on where they are and what the technology is about. So Gunter, I think, is going to present this one. I did.
Okay. Oh. Hello, everybody. So what I'm doing here, besides freezing, is coming to the realization that I've been blessed to entertain you all with my link state vector routing technology. So indeed, we started this journey about about a year and a half ago, when we started to explore this space. And about a year ago, we started with to think about chartering this particular working group. So I'm going to be covering more what it is about and some of the topics which keep us kind of warm and where we are right now with the working group. So initially, when the working group actually got started, Alvaro gave us a very clear message. He actually said okay, guys, you have 1 year to actually deliver a set of documents, and after the year, I will actually assess how well everything actually has progressed, and have to also understand if there are any real major gate stops or something like that, and then we're going to see what will be happening afterwards with the particular work. So I think at this point in time, so actually that gave us the scare of our life, because it meant 1 year to actually do anything in the IETF. That's quite a dramatical challenge. So one of the things we were, let me see if I can go there. Okay. So one of the artifacts, what we realized is that a lot of work actually is happening each time, when people go towards the IETF, do a lot of work, and then it's nothing, and then you go to IETF, do a lot of work again, and then there is nothing. So knowing our very short, timeline, what we had available, we said, okay, in between IETFs, we have to do some interim meetings. So that is what, we are doing also. And honestly, from what I'm seeing, it really helps well in keeping continuous evolution actually in your deliverables. So if you're not doing it, actually I would highly recommend to really start thinking about it. It really brings progress in the work you're delivering. So initially when we started our journey in the data center, we were just trying to understand why is data center routing different from any other kind of environments. Now, about a year and a half, a year ago, we actually did some further analysis about it. Now, I think about a week and a half, 2 weeks ago, there was a NANOC meeting, and actually it was a very good overview by Tony Lee and by Chris Martin on why the data center routing environment actually has some slightly different properties than routing in the traditional one network environment. So it actually speaks about some of the problematics and so onwards. Now at the same time, this presentation also has some interesting comparison between the different kind of mechanisms. So I put the link in here just as a background set of information. So going to my agenda, I have about 120 slides. I have about 30 minutes. So I'm trying to keep up with everybody here. So also, just be aware, I'm actually, I am the chair, but I'm not the smartest person in the room. It's if there would be any person here with a very difficult question, then we have like smarter people than me in the room actually wrote those particular specifications, so they will actually give you the answer. And the one thought actually I will give you is that the one thing that is more scary than a question is an answer. So think about that one. So that is something I've learned in my journey here at IETF. Some very smart people here. So my agenda is first to actually cover like where we are with link state vector routing. So what are our milestones and where we are and what are the deliverables. Then I'm going to give like a very high level overview about like what is the technology about. And then at the end, something, I only have like one slide because I didn't really know, what was going to happen exactly in my working group today, because, every day is a surprise and everybody, it's always like a miraculous kind of thing what happens in IETF working groups. So now I know because I just passed it, so and I'm still alive. So let's go on. So this is where we are. We started in Singapore a year ago. We are almost at the end of our journey. At the next IETF, we're going to really, try to assess how stable is our specification, where are we, and and also try to understand like where is the growing interest in from the people applying this kind of technologies. So going forward, we have like one interim coming, and then at the end, IETF 104 in Prague, we'll see what is going to be happening next. So from a milestone perspective, we only have a few because we only had a few months work to actually given to us to work on these things. So the main thing is we have an applicability statement, like where does it make the most sense to use link state vector routing? How can you apply it? Because there are like different kind of application models, how you can actually use this thing. And then we have like two other deliverables. It's like speaking about like how to use link state vector routing with standard Dijkstra, and how to use link state vector distribution using BGP transport. So the last two we put into one single document, just from a simplicity perspective and from a readability perspective, and also because we already had like some work previous ARTINET space, so it seemed as a logical thing to do to progress the work forward, because we only had like a limited amount of time. We also were given the task to actually look into Yang, so we're waiting a few dependencies there on some other working groups to progress also. Once that is done or more stable, we're going to keep on progressing that work also. Now, the good thing is that there is some sort of an ambition to keep this thing living, because March 2019 was kind of like our deadline, but this deadline for this Yang thing is like in July. So we sneaked it under the door a little bit. So we still have hopes. So looking into the LSVR components. So the way we see link state vector routing, it sort of exists out of like four different areas here. So the first one, if you look at the ground, at the bottom one, is like each router needs to describe itself, it needs to describe its neighbors, and it needs to describe the cost towards its neighbors, and it actually has to assess also some other attributes to it. But the minimum set is like, who am I, who is my neighbor, and what is the cost towards my neighbor. So you need to harvest that in some sort of a way. So that is something which can be done via a whole set of different protocols. We have been discussing the solution space for that, the different protocols, what actually are out there. The two most obvious ones which actually provide us the right hooks to that information would be like link state over Ethernet or LLDP. And right now in our working group we actually are going to start a working group adoption call for the link state over Ethernet element. So from the moment actually you have harvested that set of information, you need to encode it into something. So, and the way we encode it, we actually encode it into what we call like link state vectors. So this actually is just an encoding mechanism to describe the router itself with the neighbors and what is the cost towards the neighbors as a minimum set. So you can actually compare this as the same as like within ISAS, like a link state packet, or like SPF, you can actually compare it to a link state to LSAs basically. So that's what you're doing. Now the mechanism what we are using, a link state vector routing, because we are looking very close into like in some previous art and what worked actually well and what actually has been described already, so that we don't always have to reinvent the wheel. So we say, okay, for these kind of things, we just use like BGP-LS encoding. It's very out there, it's proven, everybody knows how it works. And from my experience, we can grow it as big as, whatever. It's like, a big, massive thing. We can do it whatever we desire. Right now, our desire is just to put like only a few things actually into it. That is just the encoding. Now, from the moment you have described your router, your link state vector, you need to distribute those things, those elements of the router between all different routers in the environment. So that is actually our flooding mechanism. So the way we are doing that, so each link state, vector can be reflected as an NLRI. So it can actually be distributed by BGP, and that's what we're using. So in our case, we are just using BGP as a distribution mechanism. Now, again, from a link state vector routing perspective, that is only one of the choices. Why do we use BGP? I will explain later on. But right now, it is seen as something which is out there, and it seems to make sense at this point in time from a time to market perspective, and it seems the correct thing to do at this point in time. Now, at the end, so the end goal is that each router will actually have the link state vectors from all of the other routers in the network environment. So that actually means each router will have like a full view of the topology. Just the same as if the router would be like an ISAS router, having all the LSPs, what the topology looks like. And from that moment onwards, you can actually start doing Dijkstra. And if you do the Dijkstra, the end result will be your routing table. So that is where we are. So that is, what is happening. And from what you can see, two top things here, in the red square. I should not really use red because red means bad. In this case, it's a good thing. It's actually what we call like link state vector routing using BGP SPF. So that's a very high level, overview. It's reasonably simple. So why are we using BGP? Because BGP is probably one of the most cool protocols ever invented. It is, because it actually pays for a lot of people, their salaries and things like that. There is like a never-ending stream of like wonderful things you can do with it. So that's why we're using, BGP in our technology, because it is just ultimately cool. Now, at the same time, it's robust and simple. Now, that is debatable, of course, Some people come up with, things to do with it, which is not really that robust and neither simple at all. But what we are doing with it is actually, we are using it in a very simplistic kind of fashion. And if you actually read the specification, you actually will understand also that what we are doing is not really rocket science. It's actually just using BGP in the most simplistic kind of version. And if you look into, even spinning SPF into it, you will see that a lot of the forwarding and a lot of the ways of, distributing all these pieces of information has been simplified also. So I will be covering some of those elements. So BGP provides us a few things. It provides reliable transport, it's guaranteed order delivery, it's incremental updates, there is like, so unlike in link state routing, we don't have a flooding problem here, okay? So there is no 25 different proposals for flooding. There is one, and it works really, really well. And it's proven to work well. It's loop-free, and it's fantastic. It's awesome. So, and at the same time, we also have like different mechanisms to actually, bring this into the network. So you can actually use like router flexes. You can use like controllers to actually program, more information downstream. And then, now the most important thing, probably from this slide, is that the way the routing actually works, everything is is computed in a distributed fashion. So there is no one piece in the network which computes the topology for everything. Everything is calculated, from a routing perspective, distributed on each single node itself. So that is an important artifact. And at the same time, a lot of people, running data centers are already using, BGP. So you have some massive scalable data centers running like, 10,000, 100,000 boxes. They run BGP. You have some other set of people who are like massively scalable data centers existing out of like 50 routers. They also run BGP because it's like really, really cool. Now we actually offer them, like a new set of technology to actually, run with this. So this is another, view. Lots of text here. Okay. Ooh, this looks very weird. Okay. That's a surprise. So the high level, perspective from link state vector router. So the target use case for link state vector routing is actually, the massive scalable data center. So the plan is to actually, bring your topological awareness and to actually do Dijkstra in networks, of gigantic size. To actually not speak about networks of like 50 routers or 1,000 routers, but like 10,000, 100,000 and more. Because that is the size of what BGP can scale to. So that is really, really nice. Now, the advantage you actually will have by having the topological environment is you can do potentially smarter things with your environment. Because if you know the topology, you can actually start doing things like loop-free alternates. You can actually avoid shared risk, risk-linked groups and so onwards. You can do some traffic engineering. Whatever crazy thing you can dream of. If you know the topology, you can actually do this. With this by extending the technology itself. The target also is to actually use this as an underlay routing mechanism. So you actually will use it as the underlay routing, and on top of that, you will have layer 2 VPN, BGP, and whatever, all of your VPN things happening, layer 3 VPNs happening on top of that. This is just underlay. From an encoding perspective, so we could have used or reused the BGP, SAFI from BGP-LS. Now, from a backward compatibility perspective, we said, okay, let's not do that, even though it's actually perfectly possible. We actually select, or will select, or we get allocated like a new SAFI for this, just from a backwards compatibility perspective. It also means we need to actually have like a new capability for this, to be exchanged. So that is important to be aware. And now for the rest, we're not really changing that much about like, the NRI distribution. Like a few things we could change, but it's more simplified. Now here you see so the reason actually I was laughing with this, so I have like this new iPad, and it's actually, iPad Pro and a pen. And you can actually make like very nice graphs with that, and make pictures. But it's not very useful being a very pro in this if you make a PDF out of your slide and it looks like this. So my graph actually is gone. So that's a bit sad. So actually what you would be seeing here, just visualize this, close your eyes. So close your eyes, dream you're in this room, fantasize about my picture, okay? And what you see here is like, a small, the different routers on the left-hand side, router 1, 2, 3, 4, and 5. And they look like routing logos. And you have like nice blue lines between them. And next to the routing logos, visualize, close your eyes, take your time, okay? You're like in Bangkok, visualize about my router, it's not about anything else. And then next to the router, visualize yourself a puzzle piece. And that puzzle piece is actually your link state vector. And that is what I'm drawing here. So I see everybody smiling. You're probably not thinking about my puzzles, I think. So, and the important thing is that puzzle actually is encoded as, in a way of like, like with the BGP LS NLRI encoding itself, with the new SAFI, which is, planned to be proposed. So that is my magic invisible slide here, which I didn't really check. I think Alvaro broke my slide with his clicking on the button thing. So I blame him anyway. So what sort of peering models do we have? So traditionally, if you look into how massive scalable, data centers are configured by using BGP, is you actually have like all routers are, directly connected with peer-to-peer, and your prefixes go, through them. So that is something which is possible also here with the link state, vector routing, mechanism. But it doesn't have to be, because if you know the topology, because lots of massive scalable data centers know the topology, you can actually download it. It is actually very well possible to actually put like, like a router reflector in place or a controller in place and peer with that one directly, so that you actually reduce the amount of peering configurations in your network environment. So those details and those specifications and some of the requirements and what can be done is actually, this, documented very well in the applicability draft. So if anybody would have, a nice question about that, feel free to come to the mic. Again, we have people here to actually answer your difficult question. So that is where we are. So the other thing to keep into mind is that what we are doing here is not a new technological principle. So what is being done here is sort of like, I wouldn't call it reinventing, but more standardizing an approach which has been used by, which has been disclosed already by Google in one of the SIGCOMM papers, like, which is known like Jupiter Rising, a decade of cluster pop. You can see what it is. So it's a SIGCOMM paper, it's open source, it's open available. And what we're doing here is actually, giving you the capability to go into the same kind of, document, technological architecture, to make that available by using BGP. So this picture actually turned out better, which is fantastic, because I didn't make it with my iPod Pro and my pen. So that's like $1,000 thrown away. So anyway, I'll give it to my kids. So a few things actually changed in BGP. So what you see here on the left-hand side is your classic BGP, decision process. What we have done with link state vector routing, we simplified that. So I know everybody knows BGP inside out, in the audience here. Huh? So phase one, normally, what you will do is that the calculation of degree of preference. So all of the routes you get for one of your neighbors, you sort of like give it a certain preference, so you can compare it later on. In phase two, you actually, compare all the prefixes you have with the preference thing, and you figure out the best one, and you put it into your local RIP. And then at the phase three, you actually start distributing those routes again towards your neighbors. So that is the traditional process. And phase one and phase two is what most people commonly know, or actually what is known as, the path vector algorithm. And that is what we are changing here. So phase one and two, in this case, is being replaced by this new thing, by the SPF algorithm. So that actually means, we're going to be doing the BGP and the right selection, and at the same time, we're going to do nearly in parallel, the SPF attached to it, so the route selection, to it. It also means that our phase three actually is simplified. So in traditional classic BGP, phase one, phase two, and phase three, they are consecutive from each other. In the link state vector routing algorithm, it doesn't really have to be the case, because we can actually do those things in parallel, which actually makes it that if you have a piece of information that needs to be transported through the network, it can go really, really, really much faster. Very similar, the same speed as a traditional IGP like ISAS or OSPF. So some of the advantages, already spoken about this a little bit. All the nodes will have a complete view of topology, so you can do like really crazy stuff, or you can do smart stuff. So up to you and what you want to do with this. Another benefit of that is that if something actually breaks in the network environment, just like with the traditional link state protocol, you only communicate the failure of what you have, because SPF will pick up and will understand and recompute the impact of that particular failure, through the topology. With classic BGP, if something actually happens, you have to re-announce all the routes sitting behind that failure again, which makes everything much more heavy, slower, and more complicated, and a little bit harder, from that perspective. At the same time, yes. If you know the topology, then you can actually make smarter or more optimal routing decisions, for the traffic through your network. You don't always have to go towards, the shortest path towards your next hub. Because you know the topology, you can make smarter decisions. It is up to the implementer, to actually, to create the code to actually, do those smarter things. So in essence, that reality is there. So almost to the last slide. So what is hot in link state vector routing? Well, right now, I think I have the impression that the drafts actually, are it's me as chair, of course, trying to, market my products here. So the drafts are like of incredibly good quality, easy to read. It will make your day happier. Even if you're in Bangkok, it's fantastic. So it's super, it's wonderful. So the BGP, SPF draft itself. So we're going to be doing a working group last call on that. We're going to be releasing that very soon. I invite everybody in the room here to actually have a very good read on that. So what we actually need to further improve these documents, because they actually went through the routing directorate, they went through the operational directorate. All of the comments actually have been addressed, but at the same time, it does really need to have like more inputs from a lot more people. The more people who can actually give constructive feedback or give information about what can potentially be changed, what is good and what is bad, please let us know so we can really, really further improve the document and make sure that what we are doing here is developing the right the right material. So that's point 1, 2, and 3. And then the other thing what actually has been hot, very heavily discussed, is as remembered, as you can see, actually as you could not see on that picture with that with your eyes closed, the little puzzle pieces. So that puzzle piece needs to be created. Now you can create this either by some sort of a divine resource, probably you configuring all of the link states and identifying that, but it's not going to make somebody who operates routers very incredibly happy, because you don't want to do that. So you want those puzzle piece. So you want the link state vectors to be created by themselves and automatically. So that means you need to have a technology out there that can harvest the right sets and the right hooks of information for you to create that link state vector. So we have been looking, around, all the different kind of technologies. We have been, ping-ponging the ball left and right and all the different things of what is available. We see the same kind of movement, in the IDR working group, and we started to compare them. Now, one of the key elements here is that the requirements, of what we have from a link state vector routing perspective are actually different from the requirements which there are from an IDR perspective. So link state vector routing as a technology is, a little bit, it's not really deployed that much because it doesn't really exist. So we're not really restrained by the fact that whatever we do has to be a technology with proven, track record yet. So we can do a bit more, we can be a bit more creative. So what we have decided now, in the LSVR working group, is to actually start a working group adoption call for the link state over Ethernet technology. So that is what it is. I have to, just a quick summary here on what the LSO is. I don't really want to go too much into it. So in essence, it's a very similar thing as LLDP. It's a simplified version out of it, and the simplified means, in the first phase, what we are documenting here is going towards the absolute minimum requirements of what we need from an LSVR perspective. So there is actually no overhead, which is a good thing. Now, at the same time, what we want to avoid is that this very simple technology excludes potential further innovation or reusage by other working groups for other purposes. So the way we are doing this is by making it extendable by using the magic of TLVs. So TLVs are wonderful. Everything is with TLVs nowadays. So we use TLVs because it is almost as cool as BGP. So we're going down that road. So that is where we are, and that is what we have right now. And again, LSOV, it's almost of a trivial simplicity, and there is no IPR attached, which is something that Randy Bush seems to love a lot, really a lot, and me too. So that's fantastic. So that is where we are right now. So that is a quick update about LSVR. I hope that I was able to entertain you a little bit, with my blessings about LSVR. So any questions, please come to the mic, but don't expect me to answer them because we have smarter people in the room. Nothing? That's scary. Cool.
Thanks. Now we're going to have Jeffrey talk about Rift. I'm learning to drive this thing. Here we go.
Okay, so my presentation is not going to be as entertaining, except I can say that the two co-chairs are Jeff and Jeffrey. That's the only entertaining part I can talk about. Why Rift? This is about data center underlying routing protocol. We have seen the evolution from IGP-based to eBGP. And what we would like to see is that we evolve to Rifts for scaling, convergence, and OPEX reasons. So the first, I want to talk about the issues with existing solutions. Why did we move to eBGP in the first place? The two main drawbacks with IGP in MSDC is that the first one is the failure impact scope. Some people call it blast radius. A small change or link up and down anywhere in a small corner of the data center is flooded everywhere, and that triggers SPF recalculation on every node. And that applies to LSVR too as well. Another issue is the rich connections in the data center network makes flooding unnecessarily redundant and inefficient. So those are the two main problems with IGP. Then people move to the eBGP solution. But there are also two issues with that. The first issue is that with a well-defined technology, a class network in data center, ideally, the routing tables could be very simple. For example, on a leaf node, all you need is a default route. On the next level, you only need a default route and more specific routes to destinations south of it. That's under normal situations. But if you do that only, and then in some situations, you may end up black holes. The next issue with eBGP is that because we have massive ECMP paths in the network, for example, a node could have 32, 64, 128 peers. And for every prefix, you would learn the same prefix from all those peers, and you have to keep all of those. So that's, in the control plane, it's a lot of resources wasted there, and lots of state to keep. So how do we solve those problems in Rift? This is the hand-drawn picture, a picture hand-drawn by Tony. He didn't use an iPad Pro. My second point, entertaining points, yeah. Okay, so if you look at this picture, we have three layers: the purple layer, green layer, and then the pink layer. So we do link states and distance vector in two directions. On the right side, we're showing that we're flooding the link states all the way from on the northbound all the way to the top. Well, actually, on the left side, we do the same thing as well. Basically, link states is flooded all the way to the north side, not to the northbound, to the top. And it also, the link state is also flooded down on the south side just by one hop, and then reflected. Let me see. Oh, yeah. So on the side, look at this pink node. Its link state is flooded down south, but just by one hop, it stops here, and then it can be reflected back to north, so that this node at the same level will keep it, will learn it. Same thing, the link state from this green node is flooded south by one hop only, and also reflected north, so that the other green node at the same level will also learn it. Why do we want to do that? It will become clear later. But anyway, so because we flood the link states all the way to the north, then every node will know the topology, full topology south of it. And then on the southbound, we use link states. We do a distance vector routing to propagate default route only by one hop. For example, this pink node will send a default route to the green node, but it stops there. And then the green node will send its own default route south. Now, we mentioned earlier that if you just do the default routes plus the specific routes for this destinations south of you, you will have a black holing issue when something happens. And here is example. Well, this slide is basically what I just talked about, how the northbound link state and southbound distance vector. So I'm going to skip those slides now. Here is the black holing issue I mentioned earlier, that if you don't do anything further, So for now, ignore that well, don't ignore anything. Just look at the picture. We have this prefix P1 here on this corner, and these two purple nodes here, they get the traffic from the servers down there, need to reach here. So let's say this leaf node gets the packet. It has two choices following the default route. It can choose either this green node or this green node. That's fine. And let's say if it chooses this node, and it again has two choices to go this one or this one. But if this link is down and this one still chooses to go this way, and the traffic will reach there and has nowhere else to go. So that's the black holing issue if you don't do anything else. Now, how do we solve this problem? We do automatic deaggregation. Remember that earlier we talked about that the link state from any node is flooded south by one hop and then reflected back. So in this case, the two pink nodes will know each other's link state. Now, this link, pink node down here, it does SPF calculation based on the topology flooded northbound. Then it will realize that it has a route towards P1 using this link here. And it also will realize that its body here does not have a link to this node here. So his body will not be able to reach P1. Once he gets that conclusion, it will send a specific route for P1 using the link, using the distance vector part of this protocol. And notice, I also note that this P1 route will stop at this green node. It's not propagated further down. It's just one hop. It stops here. Now, if you have a packet arriving on this node, trying to reach P1, and let's say this node picks, this node does a lookup, it finds the default routes, and then the packet ends up here. Now, this green node here now has two routes. One is the default route, the other one is the more specific P1 route that this pink node has automatically injected. Now, the packet will follow the P1 route, reaching this pink node down here instead of going to the top. So that's how we solve the black holing issue. So with this automatic deaggregation, we can use default routes and plus the more specific routes to the destinations south of the node. And if link failure happens somewhere, if there is a need to do the auto deaggregation, it will happen. Another important component of this Rift protocol is zero-touch provisioning. If we go back to this picture, owning these two top nodes, we call it top of the fabric, needs configuration. Very simple configurations indicating that they are at the top. Other than that, no configuration is needed on the nodes. All you need to do is to power up, connect the cables, and the nodes will discover each other, decide to set up the routing adjacencies. And if you happen to have miscabling, and the protocol will make sure that the logical topology that we obtain from the routing adjacencies that we decide to do, that the topology will be still conform to a strict northbound, southbound class type of topology. That way you don't run into routing loops and that kind of thing. So the zero-touch provisioning makes DC fabrics just like memory banks. Today, nobody configures RAM banks. You just plug it in, and it'll work. And what Rift's zero-touch provisioning does is make DC fabric like a memory bank. It's plug and play, no provisioning except on the top of the fabric nodes. There are a lot of other features, either built-in or add-on of the Rifts. Automatically optimal reduction, flooding reduction, and node balanced. We mentioned earlier that there is an issue with vanilla IGP routing, the flooding, unnecessary flooding, and that is reduced here. And it has built-in mobility support, key value store, and fabric bandwidth balancing. So sometimes you may have links going down, and now you have different nodes at the same level have different bandwidth to reach next level, and we can node balance in the traffic based on the available bandwidth. It will support segment routing. We also have policy-guided prefixes, though the segment routing and policy-guided prefixes have been moved out of base spec to their own separate specs. In summary, we combine the advantages of link states and distance vector. From the link state routing, we get fastest possible convergence, automatic detection of topology. We have a minimum routes and information on the tours, default routes normally, yeah, and so it removes the disadvantages of link states or distance vector. For example, you have reduced unbalanced flooding, you have automatic neighbor detection, and you don't have the ECMP burden there. There's unique Rift advantages, true zero-touch provisioning, minimum plus radius on failure, and so on and so forth, a lot of them. I'll just skip those small details. It's not, okay. Oh, I guess that's the last slide. So I thought I was only going to give an overview of the protocol, so I didn't put a status there, but I can talk about it. So the working group was chartered in March in London. We've had one interim meeting in May, and we have been the core team have been working, having weekly, sometimes twice weekly design meetings. Those meetings are most of them are recorded and announced. We welcome open participations, but typically it's just the core members of the team, but it's open to everyone. Our original, the open source implementation has been going on. Bruno Regisman has been doing a fantastic job with his helpers. And that overall protocol, right now we are at 03 revision. The 04 revision is evolving, and our original plan was to submit to IESG for the base protocol in February 19. We are going to have to delay that by one IETF cycle. But we are working very hard on solving the issues that we encounter, and fascinating issues. And Tony and his team can talk about those things endlessly, but I will not. I will skip those here. So that's just my report. And Jeff?
I'll add one point. The way we develop protocol, we do it the way IETF should do it. Everything is being coded as we develop the spec. We found number of issues in code that were fixed in the spec, so both go in parallel. We make sure the stuff actually does work. It's not only PowerPoint and beauty.
Yeah, another thing I forgot to put there, and I know that Alvaro wanted to hear about, is the thrift model. We actually, last time, we actually talked about this extensively in the working group meeting. So in old days, routing protocols are specified with packet formats, and this byte and that bits for whatever. And with Rift, we don't have packet format, the old style packet format definition anymore. Everything is Rift model based. That makes development a lot easier. You just use a tool to compile the Rift model, and then you automatically generate codes to handle the coding and decoding. That speeds up the development extensively. A lot of people were last time had lots of discussions on that. It's truly a wonderful thing. I think that's all I have.
Hi, Victor Coursing. One quick question. How does Anycast services work on the underlay within the Rift model?
I see Tony is standing up.
Anycast. Underlay.
All right, so in the press, I mean, lots of stuff has been suppressed. So Rift is loop-free, which means you can take any path to anywhere. So if you have Rift is doing true Anycast, so not this Anycast like IP, which is bound by ECMP basically, but Rift, when you see the same address on the fabric, doesn't matter what the distance is, and you can split the traffic also at any, based on the bandwidth, distance, whatever you want. More than that, what we have is a fast mobility, because when you start to move things on the fabric at a certain frequency, you start to confuse mobility for Anycast, right? Depending what gets an update first. So Pascal put it in, and we actually changed the IPv6 low pan for that purpose, because they're facing the same issues, that if the fabric has a clock, and we don't care how precise is the clock, we can actually make a distinction between a move and an Anycast. And because we see the timestamps, only the newer direction has to get there for us to flip over, and we don't have to wait for the old address to be withdrawn. So those are all things which cannot be achieved with normal IP protocols, which rely on ECMP and cannot do the timestamping. So that's so far for the Anycast. I think nothing comparable exists.
Thanks, sir. Okay, any other questions? Nope. Okay, so now we get to the part of the agenda where we're just opening up the floor. Anything you guys want to talk about, comment on, tell us a story, complain, coffee is not there yet. I think we already had the last coffee for today.
So, Lo Anderson, I have a real nit. We got the mail, or the working group chairs got the mail from the ADs, how we in the future need to update the working group status. I think it's a brilliant idea. It's the right place to have it. Though, when you look at the working group page, it's extremely hard to actually find the working group status where you need to click to find it. Would it be possible to talk to the data tracker team to move a new button up on the top line so we actually can find it easily?
Sure, you can talk to them.
No, I think it's actually.
I think I can solve your problem.
Okay.
AC Linux Cisco Systems. I was able to edit the main working group change and put a link, a URL link right there to the status on the LSR page. So I don't have to have two separate.
So wait, so this is the LSR page, so they can show us. Hold on.
Okay.
Well, maybe it didn't work.
Wait, that's not the LSR page.
Yeah. Is it coming? Oh, there we go. Yes.
Okay, go. You see that current working group status right there? You can push it. Click on that. No. Go down, up. One. No, up. There you go.
Yeah.
There it is. Now click it.
Yeah. So right.
What I'm saying, I want that bottom up on the. This is fine. The content is fine. No, it's the previous page.
Yes, I see what you mean. Yes.
So instead, about on the same level as about
you want the tab up there.
Yeah. It's a net. I said it was a net.
Okay.
But
Well, we're not logged in.
so if I talk to the data tracker team, can I say that we discuss it in the routing area and we agree that it would be a good idea?
Yes, actually, if you, for those of you who, I guess have privileges on the data tracker for the working group, I guess the chairs and the ADs, when you click on the status update to edit it, at the bottom, the tools team put in a little history of why they put that there. And actually the history has to do with us, with the routing area. They put it in there because we told them we were doing summaries. And so they put that there so we could put the summaries in. We had never used this, so I originally thought that what would happen is that there would be a little window-like thing right here that would show the actual summary. So that's why when I sent this to the chairs, we said, let's do this a couple paragraphs or something. But I think a tab is a great idea, and since they did it for us anyways, it would be just.
No, you go. Especially since you said it's for people not kind of very actively using the data tracker. They need to find it directly, and I think it's a good idea, but an improvement needed.
Stuart, so if you're going to find it where you expect to find it, in some ways it really belongs on the bottom of the charter, because the charter has got the current status of the working group. It's got what its work package is. It's got what it has done, and it's got what it is expected to do. And isn't that exactly status information, and where you'd expect to find maybe an amplification of the status information?
Well, so I think we closed OSPF at the beginning of the year, right? The last time we rechartered OSPF was in 1984 or something like that. Yes, ideally that. Also, ideally, now that you bring it up, I think it's a great suggestion for the chairs, from an active chair, to keep your milestones updated so that we can see.
That's our job for Saturday breakfast.
Whatever, just do it. So that we can see the actual status of when you're going to deliver things, etc. So the intent of the status update that we're talking about is that here's a short summary, because yes, okay, when you go read the charter, you know what the working group is supposed to be doing. We want to know, especially for, as we said, external audiences, what the working group is doing now. If I'm interested in any working group, let's say LSR, what is it discussing now? Is it worth for me to go to the meeting? What are the drafts that maybe I should go read now? Because otherwise you look at the document page and there's a lot of documents, and it's not necessarily easy for anyone not following the working group to tell exactly what's going on.
So, Stuart, again, maybe the right thing, because you should always do call by reference rather than call by value so that you don't get inconsistency problems. Maybe the right thing to do is at the bottom of the charter page to have a pointer to current active status.
Okay, so this is obviously the first time we're doing this status page thingy. Keep the suggestions coming, and we'll experiment with this further. Anything else anyone wants to say? Okay.
Scheme amount has been submitted, and whatever was in misrep for the last 35 years is true.
So I have, Stuart again, I have one other comment, which is, am I the only one that thinks there are too many routing group overlaps in the meeting agenda, where there are important meetings that you need to be simultaneously at the same time? And is there anything we can do to try and reduce this?
To your first question, I don't know. Who else thinks there's a lot of overlaps? What? So, yes, there are many things, or there are some things I guess we can do about them. The first order is, of course, the conflict list that is put into the session requests. And please revise that. We had tried unsuccessfully before to try to prioritize that list so that it would be easier for the Secretariat and for us to understand the specific conflicts that we have. We usually try as much as we can to avoid any significant conflicts. However, there's always going to be something. Maybe we can avoid more than we have avoided now, but yeah, that's the initial step. The other thing that would be really useful for us is, as the preliminary agenda comes out, if you see anything that we should be avoiding, let us know and put it on the conflict list for next time as well, so that we try not to keep stepping on that. But yes, I mean, we try to do the best we can. This week, because we had one less day or half a less day, maybe there were a little bit more conflicts, yes.
Andy Malice, yeah, I'm personally unimpressed with the Friday experiment that's going on here this week. And I was hoping if the three of you have a consensus on that between yourselves, you bring that back to the next time the IESG meets, so we can perhaps avoid this in the future.
Andy, one question for clarification. In which sense unimpressed? What is bothering you?
I think it's a waste of a day. There's only like 4 small groups that are meeting tomorrow, if that, based on what I saw on the room reservations. I think it's a waste of the resources that we're paying for in the hotel. And I think a much better use of the day is what we've done in the past.
Thank you.
Yeah, I do want to say that there are actually more than 4 meetings happening tomorrow. There are meetings that are not on the schedule on the wiki or on the slides that Alyssa put out yesterday. They just haven't been announced there. Still, it's not full load of working groups meeting. So yes.
Tony Lee, Arista Networks. I agree completely. We should reuse Friday. If we took all of our routing meetings and spread them out a little bit more, we'd have less overlap. Pretty obvious.
Enthusiastically support to previous speakers, Greg Merskiziti. Yes, please. Even their time we used to have on Friday for group meetings helped to relieve conflict. And another plea to working group chairs, please be very considerate when you request working group sessions, listing possible conflicts with other groups in the area, at least in the area, because otherwise running from one group to another to have presentations here and then presentations there, it's a lot of stress.
Stuart, if I could say something, then you can answer my question too at the same time. So one of the ideas actually kicked out, which was might be even more revolutionary, was that to just have 1 hour sessions for all the working groups, that they more effectively make, use of their meeting time, and they could use interim meetings, for other, discussions, but to go just to 1 hour. And our routing area actually is one of the only ones that really requested, their 2 hour sessions, 2.5 hour sessions, whatever. So do you really feel, right, that, because that would reduce the conflicts too, is right, if everybody just went to 1 hour.
That's not enough.
But do you really see the utility, right, to have the discussions in person? Maybe I'm leading in, but right, that we have in person, we're here, and that we make good use of that time, right, to have the 2 hour sessions.
David Black, this time I'm here from Transport and I'm here to help you. I have ran a working group that met for 3 hours total this week, and we could have used 4. And yes, that's for face-to-face discussions to work through hard issues.
I kind of support what David said, but I was going to take a different point, which is that we use the 18th century method of figuring out conflicts, right? People who understand what's going on sort of figure out from what they know what the conflict should be. We live in the 21st century with big data and all those sorts of things, so it should be possible to generate a conflict hint using what we know about who was in the meetings and who the draft authors are and the overlaps, etc.
Stuart, I guess we would be using information that we would need to be careful on how we use that information, because that would necessarily point to people and understanding where people are at which time and so on.
Well, even if you didn't figure out from the blue sheets, which you probably could do, are they online? I'm not sure. With modern handwriting techniques, even if you didn't do that, you could at least figure out who was active in which area and try and minimize the overlaps. You could do that from the mailing lists, which are public information. You could do this from the author lists, etc.
Yeah, I just want to point out, not one more excuse, but one more circumstance this week. This week, for the first time, we added a conflict with every working group for the routing area working group. So it used to be that in the past, we had other routing groups meeting while the RTGWG was meeting. So this time we deconflicted that, which of course, led to other things. Go ahead, Tony, and then I want to ask another question, similar to what Deborah asked before.
I want to give you something positive. Food was great. Too much. But too much.
So we didn't have anything to do with the food, but we'll take all the credit for that. If we're going to take the blame for the rest of the ASG, we'll take the credit for the food. So we talked about the fact that mostly the routing area groups, some of them are the ones who select some of the bigger slots. One thing that we had to do this week was have maybe 2 sessions, a 2-hour session and a 1-hour session maybe later. And a couple of groups met twice, but at different times in the week. Do you guys think that was useful, or will you rather have one bigger slot at one shot? Just show of hands, who thought a bigger slot would have been better, and who thought it was fine to meet twice during the week at different times? So 1 and 1, so it doesn't matter. Okay, great. That's what I was looking for.
Jacob Height, Cisco. This is not a comment just for the routing group, but I think the whole of the IETF is, when do we move on from ASCII? Because every other standards body I know.
So, yes, the RFC editor made a presentation about that last night. They're already testing non-ASCII characters. You can do drawings, except don't use colors. So that's it, yeah. So there's a couple of RFCs actually to talk about the changes, and you can go to the RFC editor page and check that out.
Of all the working group, all the areas in the IETF, colors would be most useful in this one, because we have to deal with situations where you have multiple overlapping topologies, and colors would be much better than the other alternatives.
I think the address is rfc-editor. That's somewhere, I don't know. Maybe rfc@rfceditor.org. By the way, just in case you don't know, the people who manage the RFC editor activity are the IAB. So sure, we can tell them, but please, you can tell them yourself as well. Yep. Oh, Jeff is from the IAB. Jeff, anything you want to say?
So you should have been, yes, or maybe not. Heather presented twice our plans with regards to new RFC format to support colors, to support different formats, to show them properly in HTML. It's all coming. Just be patient. They're not. If you do text, you can't use colors. Otherwise, you can use colors.
No, are you sure about that, Jeff? I think it's color anywhere. It's colorless, full colorless.
You could still do PDFs, and in PDF you could use whatever you like, right? If you,
Years ago.
that's why our documents are so much better than theirs.
So please take that discussion to the RFC editor list. Maybe there's something called RFC intros or something like that. Anything else that we can actually do? Okay, thank you so much, and we're going to see you in Prague. And by the way, we still have another half an hour of meeting time, so stick around, talk to each other, tell each other jokes and what the heck you're working on and all that stuff. Thank you so much.
No, it doesn't. I know. No, it doesn't. We have lots of counterexamples from this. Insights. That's part of my